my name's James Thomas. I'm a developer advocate for IBM working in our cloud division. And today I'm going to be talking to you about a new way to build and run microservices, APIs, backends in the cloud without having to set up and manage any infrastructure to be able to do this. Right now having to provision virtual machines, now having to create containers, now having to install Linux database servers and all that kind of stuff. And this might sound kind of impossible, right? Microservices without servers. Because surely if you want to run your backend in the cloud, you have to set up and manage the environment to do this. But I'm going to be showing you a new approach using what they call serverless cloud platforms that allows you to do just that. In the second half of this talk, I'm going to do a live demonstration of using one of these platforms to create some sample services and give you the tips and techniques to go away and kind of do this yourself. Now, as well as this sounding kind of impossible, right, microservices without servers, you might also think that it sounds unnecessary. You might think, I like my servers, I've got them all configured and set up just how I want them, right? Why would you want to take my servers away from me? Well, the reason is this, right? Servers are killing your productivity, and you might not realize it yet, but trust me, it's true. And I think by the end of this talk, you're going to agree with me that servers kill your productivity, and you're going to want to go back to your office on Monday, gather up all of your Linux machines that power your application, set them on fire, and be free forever of the tyranny of looking after infrastructure. But I think servers are just one of the worst things that's ever happened to software developers. So why am I so convinced, right, that servers kill your productivity? Well, imagine you have a brand new idea for a new application, new startup, a new product or a service, and you're a developer, right? So you can write the code. And you've got some customers who want to try it out, which is also quite good. So you spend the next couple of weekends furiously coding away in your spare time to build your kind of MVP. And you've got some people who want to try it out. So you think, okay, I've got my code. I'm just going to provision myself some servers, some environments, put the code on there. People can start to use it, and then everything will be wonderful. But what you'll suddenly discover is, as soon as you provision that first environment, right, that first VM, that first container, that first kind of infrastructure as service, that suddenly you have all of these extra tasks to take care of, right? If you're using things like VMs, then you have to set up and manage the Linux environment, get your middleware on there, you need to keep it updated as new software versions come out. You need to think about capacity planning, resource planning, right? How much capacity do you need? How big a VM with memory and CPU disk space do you need to allocate? You also need to think about security, right? Is your server backed up? Is it encrypted? Is it secure? You don't want hackers to get in and steal all of your data. And then hopefully, as your backend, your product gets popular, you're going to need to think about scaling. And scaling for most people means more servers, more environments, more VMs, and then you can run them in a cluster, and you have to worry about scaling and failover and replication, all this really hard distributed computing stuff. And after a while, I think as software developers, it can often feel like I'm held hostage by my infrastructure, right? I want to spend all my time in my IDE writing code, and I spend too much of it kind of logged into some remote Linux terminal trying to fix production issues on my infrastructure. And this is not really what I want to do. I'm a developer, I want to spend time in my IDE, not on managing kind of sprawling VMs in the cloud. Now at this point you might want to stop me and say, well, hold on, James, right? Wasn't the cloud supposed to fix this? I've always been told as long as I put my backend in the cloud, all my infrastructure challenges just kind of magically go away. And I think in the technology industry, we sell cloud as this utopian vision, right? The cloud allows you to treat computing resource just like a utility, like electricity or gas or water. We just provision as much infrastructure as you want on demand, elastically. You pay for what you use, and when you're done, you just kind of throw it away. But for many of us who do build in the cloud today, I think what we've discovered is that the way we use and provision infrastructure in the cloud is not really what we think of, or I think of, as much of a utility model for computing. So let's take a utility that we all know and use at home, right? Let's think about electricity, and think about how we use electricity and compare that to how we use infrastructure in the cloud. So I've got a couple of questions to ask you, right? Does your utility provider, does your electricity provider ever ask you, do they ever ring you up and ask you at the weekends to go down and maintain the power station? Right? Hopefully no, right? No, you don't get any calls from your electricity providers to go and do this. You know, you just use the power. You don't need to think about maintaining the equipment. But with the many cloud services, cloud infrastructure services today, although the servers might be virtualized, right? So you have to physically buy the server and then kind of plug it in anymore. You still have to maintain the environment your code runs in. You have to update Linux and the middleware and the operating systems. And that's not really what I think of as a kind of utility model. Also, does your utility provider, right, do they ever ask you to do capacity planning up front when you get connected? Do they ever say when you ring up to get electricity from your provider, well, how much do you need in 6 months' time, so we can make sure that we connect you to a substation that's big enough? And again, hopefully the answer to this question is no, right? If we just use electricity or water or gas, I don't need to think about how much I need in the future. That's the platform's responsibility. But again, with many cloud systems today, right, if you're provisioning VMs as a service, you have to decide up front how much CPU and disk space and RAM you need for capacity that only is going to occur in the future. And it's very hard to predict how much traffic you're going to get in 6 months' time because, you know, it's in the future. And then finally, does your utility provider, do they charge you for unused capacity, right? So do they ever say, you know, you get your bill at the end of the month and it says, you know, this is how much electricity we generated, so you have to pay for everything we generated? And hopefully no, right? Normally you only pay for utilities the amount that you use. But again, with many cloud systems today, you decide up front how much capacity you need. And then if in the future that load, that traffic on your backend never arrives, you have idle servers, idle applications, well, guess what? You still have to pay for it, right? You have to pay for the capacity you reserve, not really the capacity you use. And again, I think this kind of shows that the way many of us use the cloud today isn't what we think of as a utility model that we all talk about. So the question is, obviously, well, what can we do, right? I still need some way to run my application, my backend, and obviously want to run in the cloud. But what's a kind of alternative? And that's what I'm here to kind of talk about today. I'm going to introduce something called serverless cloud platforms. And serverless cloud platforms are billed as this next generation cloud computing service that the first time allows you to treat computing resources, computing infrastructure as a pure utility model where you just use it automatically, you only pay for use, kind of provisioned on demand. So let me ask you to see who's in the room, right? Who's heard of this term serverless before? Right, I have, because that's what I do over there. Okay, so just around half of you. Has anyone been trying out any of these platforms, things like AWS Lambda or OpenWhisk or Azure Functions? Okay, 1, 2. Okay, so not so much. That's generally about right. When I talk about it, about half the people in the room have generally heard of it, and less than 10% have really been playing it. But if serverless is very new to you and you're like, okay, well, what is this serverless thing? You went to Wikipedia and you would read on the article things like, you know, serverless computing, it runs your code in response to events, right? Manages all your computing resources for you, allows you to build event-driven applications. And again, you might kind of stop and scratch your head at this point and think, well, you know, all cloud platforms forever always say this kind of thing, right? Why is this really different than how I already build software in the cloud today? But serverless platforms are different, and they're different for a couple of reasons. The first is that I think they shrink the unit of deployment. So rather than having to deploy your application wrapped in a huge VM image with all the operating system and libraries and middleware and databases wrapped in, or even as some monolithic deployment package with loads of class files and XML and all that kind of stuff, serverless cloud platforms allow you to push the raw function code, source code straight up into the platform and have it executed automatically on demand whenever API request comes in. And this is where the term serverless comes from. It's not that there's no servers, right? Code's still going to run on a server, but what's going to happen is that all of the responsibility for managing those servers is going to be pushed over to the platform, and as a developer, all you really have to focus on is writing the code. And then your code gets started on demand in milliseconds to process requests as they come in. Your application, your microservices, they don't sit there idle waiting for those requests to arrive. Another difference about serverless is the scaling. All right, so scaling is now the platform's responsibility. When you get lots of requests, lots of load on your back end, all that happens is the platform has to start up and instantiate environments to process requests in parallel, what we call kind of horizontal scaling. So it's not something you as a developer really have to think about much as long as you follow those kind of architectural guidelines. And serverless platforms, as well as scaling up, right, to cope with loads of traffic, they also scale down, and they scale down to zero. Because your code, your microservices are only running when there's data to be done, when the requests come into process. So most of the time, right, if you have some idle time in your application and you've got no traffic, none of your code is actually running at that time. That's really, really important when we think about the pricing model. So serverless cloud platforms, like all APIs today, is pay-as-you-go, right? You pay for the milliseconds that your code is running to process those requests. But with serverless, right, I said before, your code is only running when there's actually requests to process, and there's messages on the queue or events to be able to process. So all of the idle time that you have in your application, guess what? Now you don't have to pay for it. And I think this is the most underappreciated aspect of serverless, the fact that you don't have to pay for idle time. And this can lead to some really disruptive effects and costs, right? There's lots of use cases you can read about online of people saving 80, 90, 95% of their monthly infrastructure bill from their cloud provider by moving from certain workloads from VMs as a service over to serverless, because they don't have to pay for any of that idle time anymore. Okay, so enough talking about serverless at a very high level and abstract sense. I want to kind of show you actually how to use one, create some sample services, and show you how easy it is to kind of get started. So if you want to get started with using serverless platforms for development, the first thing you need is a serverless cloud provider. And today there's literally like a dozen you can choose from. Serverless is a technology started almost just over 3 years ago now, when Amazon came out with a new service for their cloud called Lambda, and kind of kicked off this whole new paradigm of building software in the cloud. But I think last year, the start of 2016, was the year that serverless really took off with developers. One of the ways you could see that is that all of the other big cloud providers kind of came on board. So they looked at Amazon and said, this seems like a good idea, we're going to launch our own competing solutions. So IBM, who I work for, has one called IBM Cloud Functions, I'll be looking at in a minute. Azure Functions, Microsoft have one on the Azure platform called Azure Functions. Google Cloud have one called Google Cloud Functions. There's a number of open source projects available now that build on top of things like Kubernetes as well. So as a developer, whoever your cloud provider is, I kind of guarantee you they have some kind of serverless offering for you to be able to play with. And they all work in roughly the same way. It's kind of functions on demand that you can connect to event sources. So the techniques and the architectural patterns I'm showing you today are really applicable to any cloud provider. Now, the one I'm going to be looking at today is based on a project called APACHE OpenWhisk. This is actually the platform at the heart of IBM's commercial serverless offering, that when we developed it, we open sourced the entire platform and we've donated it to Apache, and it's a full Apache, well, it's going through the incubation process for Apache at the moment. As well as IBM, both Red Hat and Adobe have recently been kind of interested and adopted it as their serverless platform. So it's not really just an IBM thing anymore, it's got a couple of different vendors working on that and using the platform. But if you are evaluating, okay, so which serverless provider do I want to use, there's dozens to choose from, I think there's a couple of good reasons why I really like Apache OpenWhisk as a platform. The first, obviously, is that it's open source, right? So you can go to github.com/openwhisk, you can dig into the Scala code that powers the platform and understand how it works under the covers. And actually most of the service platforms out there today, especially hosted in public cloud, are commercial, they're not kind of open source. And the reason that we did this is that we think everyone who builds on the cloud has some kind of existential fear about vendor lock-in, that you're going to be tied to some proprietary cloud service for life, and what happens if they turn it off or they make it very expensive, you're going to be stuck. You remember what happened to services like Parse.com. So we think by open sourcing our cloud platforms, it gives you a bit more security. If IBM goes away tomorrow, which I hope won't happen, then you still have a way to kind of run your OpenWhisk applications. Another nice thing about OpenWhisk is the runtime support. So these are the runtimes that come kind of out of the box at the moment. And if you look across all the big serverless providers, there's some very common runtimes and some which are much more provider specific. So for example, Node.js. Node.js is the first class serverless language. Every platform out there kind of supports Node.js out of the box, and so does OpenWhisk with Node 8 at the moment, or Node 6, we're about to go to Node 8. And Python's also relatively popular on most platforms these days. OpenWhisk supports Python 2 and Python 3. Java also is still relatively popular, so OpenWhisk, you can use Java 8 on the platform, Lambda is the same, Azure Functions is recently adding support for Java as well, so it's getting fairly good support out there. Some of the runtimes are a bit more OpenWhisk specific, so PHP has now been added, so this was contributed by an external open source contributor to the project, it didn't come from IBM or Red Hat or Adobe, which was very nice to be able to see. IBM's also added in support for Swift. So Swift was a language that Apple developed for doing native iOS development, and then they've open sourced it a couple of years ago, and people are building backend apps now in Swift as well, and IBM's been heavily involved in the cross-platform support. So we added Swift into the platform, which means, I think is great, because if you're a mobile developer, right now you can build your backend APIs in the same language as your front end. But finally, the best thing I think about runtime support in OpenWhisk is that it's extensible. So actually, you can push up custom Docker images with any runtime you want as the platform and pretty much execute anything. So if you want to do Kotlin or Erlang or Haskell or something like that and write your serverless functions in those languages, it's absolutely possible by pushing up custom Docker images. And that's something also that many of the more commercial, non-open source platforms don't support at the moment. Lambda doesn't support it, Azure Functions. It's a very OpenWhisk specific feature, which actually I think is really, really powerful. So once you've chosen your serverless provider, right? In this case, you're going to use Apache OpenWhisk. The next thing you need is you need to write your code, right? You need some microservice code. Today I'm going to be looking at JavaScript as the language because I think it's not too. Most people can tolerate a little bit of JavaScript. But the question is, when you have, so you finish your code in Java or Python or PHP, whatever runtime you want to use on one of these platforms, the question people have is, okay, you told me I just push my code into the platform and it gets executed on demand, but how does the platform know what to do with it when those requests come in? And it kind of works the same way on any platform. All you have to do is, in your microservice code, you need a particular function interface that's going to get called by the platform. So there's a particular function that you add in, and that gets called every time an API request comes in with the event parameters, and whatever you return from that function is going to be serialized back out as a response of your computation. So for example, this is for JavaScript. This is what it looks like, right? This myservice.js file, it can be like 100, 1,000 lines long. It can have lots of functions. It can use third-party libraries, no problem. And all you need to do to make it compatible for OpenWhisk is have a function in there, a global function called main, which takes an object and then either returns an object or a promise, depending on what you're kind of doing. And that's all you need to do. It's a very, very lightweight way to make your code compatible with one of these serverless platforms. I know obviously lots of Java people at the conference, so this is what it looks like for Java. And semantically, it's the same, right? Again, in your class file that you've written, all you need is a public static main, which takes a JSON object using Google's JSON library and returns a JSON object, and everything else is handled by the platform, which is pretty neat. So once you've got your code, and you add you write the code, you add your interface, the next thing you need to do is you need to push it into the platform. With OpenWhisk, when you push your serverless functions into the platform, we create what's called an action. So an action is just the name we use for your serverless functions that are deployed on the platform, ready to be kind of invoked on demand. So let's have a look at doing this now. Let me take some development code from my laptop, push it up to OpenWhisk, and show you how easy it is to create some of these serverless functions in the cloud. So I'm going to sit down for this. I'm going to hide my slides and then go back to screen mirroring. Okay. Okay, so make this a little bit bigger. So as I said, OpenWhisk is open source, right? So if you really want to, you can go to GitHub. You can pull down the whole platform and run it locally in a VM if you want to play around and just like to kind of test it out. But I think with serverless in general, the easiest thing to do is go and sign up for an account with one of your cloud providers, and they always give you a very generous free tier to get started. And IBM's no different. So in IBM Cloud, we have a service called IBM Cloud Functions, and it's just a hosted open source platform that is run as a kind of managed service for you, and it comes with a very generous free tier. And that's the one I'm going to be using today, but you can use any OpenWhisk platform endpoint. It's just the kind of same open source platform. So the first thing you need to do is you need to be able to get a code that I finished on my laptop up into the serverless cloud platform. And the way generally we do this is there's just a little command line utility you can download and install to be able to create serverless functions, to be able to invoke them and get the results of the computation, all that kind of stuff. And you can see you can just follow the instructions to download a little binary for your operating system and kind of get started. So as I use OpenWhisk all the time, I actually already have this deployed. So you can see I have this little utility, WSK, which I'm going to use to interact with the remote cloud platform that I'm kind of using. And we can do a quick Hello World example now. So I have a tiny bit of JavaScript code that I want to deploy. So you can see this is the world's smallest microservice. It's only 4 lines of code. And essentially in this file it's just a function, right? And it's a function called main. Let me make that a bit bigger. There we go. Right, so it's a function called main. So this is the interface that OpenWhisk expects. That function is going to get called by the platform whenever it's invoked. It's going to pass in the event parameters, and it's just going to return me a greeting string. It's going to say hello world, or hello James, or hello Sally, whatever I passed in these event parameters. So let's just quickly deploy this and have it running as a scalable cloud function. So using the command line, I can say, okay, whisk action create. I give it a name, call it hello, and then obviously you give it the path to the source code because I said it pushes the code straight into the platform. And if the internet is playing around, I can check that it's been deployed correctly. So let's have a look. Yeah, there we go, right? So you can see my workspace on the remote cloud instance. I've got this little cloud function called hello using the Node.js runtime, which is what it's supposed to. So now I can test it out, right? Say whisk action invoke. I give it the name hello. and it should just give me back the results of calling that JavaScript somewhere in the cloud, on a server, on a VM container, all that kind of stuff, and serialized back out as JSON is the results of that JavaScript being executed. And I can call this again. What was it looking for? It was looking for a user. It's with my name, or I can say Sally, and it's just going to work. Right? I could call this serverless function like 1,000 times in parallel, and it would just work. I don't need to worry about capacity planning or set up node environments and all that kind of really boring stuff. So really, really quickly, I've taken some code from my laptop, and now it's kind of running to call via the platform API. Now, this obviously tiny 4 lines of JavaScript is not particularly useful as a kind of service for your application. So let's look at a slightly more realistic serverless function. Let's imagine you work for a retailer, right? You're building a front-end website for a retailer, and they want to integrate Bitcoin like everyone does into their application. So during the checkout process, you can pay with your Bitcoin. And Bitcoin as a currency fluctuates, very volatile at the moment, right? It changes pretty much minute to minute, hour to hour. So you're not going to embed the Bitcoin prices for your products in some database, right? You want, during the checkout process, some API you can call to do the real-time conversion of the price. You think serverless functions would be a good way to implement this API. So I have a little bit of code to be able to do this. And we'll just kind of walk through it, and then we'll get it deployed and show you it working. So let me make this a little bit smaller so it all fits on the screen. There we go. Okay. So again, it's just a dozen or so lines of JavaScript. This is going to be the entry point into the code. It's going to call the function main anytime it's executed. It needs to have 2 parameters. It needs to have an amount and a currency to be able to convert into Bitcoin. And then what happens is the code goes and does a HTTP request to another API to get the current prices of Bitcoin in certain currencies. So CoinDesk is a Bitcoin wallet that publishes real-time Bitcoin prices in a JSON API. It uses a third-party library as well that's available on the platform. And then down the bottom, it just does a tiny bit of math, right, to be able to convert between to your currency and Bitcoin and returns you the result. So if I want to deploy this, I just say, okay, whisk action create Bitcoin. I give it the, what's it called, conversion.js. And now I can invoke it. So I can say, okay, whisk action invoke Bitcoin. And I need to pass in the parameters. So let's do amount. Bitcoin's super expensive, so let's do like $10,000. And currency, US dollars. And hopefully it's going to go and tell me that 10,000 US dollars is just over 1 Bitcoin. Bitcoin's very expensive at the moment. And I can try different currencies. I can try euros or pounds. And it's just going to work. Right now I've got this little serverless function that I can call really, really quickly, just with a bit of JavaScript from my machine. So that kind of sort of introduces a little bit of the development workflow and how quickly it is to kind of get started. The next thing to talk about is when you have your serverless functions deployed on one of these platforms, or how can you integrate them into your application? How can you call them programmatically to be able to use them in other applications? And in OpenWhisk, you have a couple of different ways to kind of invoke your functions through the platform. The first is using something we call the platform API. So the OpenWhisk platform has a very open, well-documented, with Swagger docs and that kind of stuff, RESTful API to interact with the platform. So if you want to create new serverless functions, you want to invoke them, or you want to get the results of computations, all you have to do is be able to send a HTTP request to the platform API, authenticated with your developer credentials, to be able to do that. And there's also client libraries available for lots of languages like Java and JavaScript, that makes that process really, really easy. So you don't have to manually construct the HTTP headers and all that kind of stuff. You just can use one of the client libraries, and all you have to do is use your developer credentials you're registered to be able to authenticate with the platform. And so obviously any application, mobile app or something like that, or backend app that you can make an authenticated request from, you can call your functions on demand. Now obviously if you're building things like APIs or endpoints, public endpoints with serverless functions, often you want some public endpoint. So you want a HTTP endpoint you can call to invoke your function without any credentials. You don't want to leak my credentials to the world if I'm using it from a client-side JavaScript app. So actually, OpenWhisk has a couple of different ways to do this. The first is using something that we call web actions. So web actions, when you create your action on the command line, there's a flag you can set, --web to true, And what that means is the platform will generate you a unique URL on the platform that you can then call with a normal HTTP request, GET request, but without any authentication whatsoever. And this is a really, really nice way to turn your serverless function into a public endpoint with kind of minimal effort. So again, you still call it through the platform API on a unique URL that it gives you, but this time you don't need any authentication. So if you want to do like something quick, like a webhook endpoint or a chatbot or something like that, web actions are a really awesome way to be able to do this with kind of minimal effort. But if you're building like big, very enterprise, high traffic APIs, you're probably thinking, okay, well, what about like API routing, right? I want to be able to call different serverless functions depending on the path and the operation of the request coming in. What about rate limiting? Don't want to call my function too much and charge me too much money. What about things like authentication? I want the user to be able to provide OAuth credentials that I can use for backend services, and I need to be able to handle that. And if you're using web actions to create your APIs, you have to handle all of that kind of stuff in the code itself. You need to look at the request parameters coming in and work out how to implement things like rate limiting. And that's not a very scalable approach if you're building big, kind of high traffic APIs. So what everyone does in this instance, the architectural pattern in service development for doing this kind of stuff, is using another cloud service called an API gateway. So all big cloud providers have these services. IBM has one called API Connect, Amazon has one called API Gateway, Google acquired APACHE recently to be able to do this. And what API gateways allow you to do is create public API endpoints that then will call private APIs in the background and kind of proxy the results kind of back and forward. With OpenWhisk, it comes with a built-in API gateway that allows you to create these public endpoints for your serverless functions. And the great thing about API gateways is they can handle all of those features for you, right? So you can turn on rate limiting or routing and authentication, and it's all managed in the API gateway service. You don't need to think about that in your code anymore. And it's a really, really awesome pattern. So as you build bigger, more high traffic profile APIs, you're going to want to use one of these API gateways to expose your functions. Okay, so let's do this, right? Let's take the little Bitcoin serverless function that we've tested and we know it works, and let's expose it as a kind of public URL on the internet that we can show how easy and quick that is to do. So I'm going to hide my slides again and mirror my screen. Okay, so here we go. Right, we're back on the command line. Good. So the first thing I want to do is let's try the web action because that's really, really quick and simple. So my Bitcoin function's already deployed, so all I have to do is I'm going to say update rather than create because it exists. And I'm going to set that flag --web to true. So --web true. It's going to say OK. And then I'm going to ask it for the URL. It's going to give me back the URL. It's going to give me back the URL on the platform that we can then hopefully talk to. Come on, conference Wi-Fi. Yeah, there we go. Good. OK. So now I'm going to say, OK, give me the URL. Retrieve details about the Bitcoin action and give me the URL. And hopefully, when it comes back, I'm going to be able to make a HTTP request to that endpoint. It's going to just give me back some JSON. So, okay, so I can say HTTP GET, and I'm going to copy the URL here, and I'm going to paste it in there. And this is just a command line utility that allows me to make HTTP requests. So I'm going to say I want back some JSON, bitcoin.json. I'm going to pass in the parameters as query params in the URL. And hopefully this should work, right? So it's going to there we go, it's already done it, right? I've now got the same parameters back, or I've got the same response serialized to JSON, but now it's through an external HTTP endpoint that I could use in any application, right? So for things like webhooks and chatbots, this is a great way to expose your functions as public URLs without too much work. Now imagine my Bitcoin API gets very popular. I need to worry about rate limiting and authentication, all that kind of hard stuff. So let's quickly expose it using one of these API gateway services. Now, as I said, OpenWhisk comes built in with an API gateway, which is really, really nice. And you can control it from the command line. I can say whisk API create, whisk API delete, and give it a Swagger document and that kind of stuff. But I think it's more intuitive if I show you through the web interface. You'll see why, hopefully, in a minute. So again, if I go back to this is just the web UI for the managed version of OpenWhisk running on IBM's cloud. I have this little tab that allows me to create APIs using our API gateway.
Besides the API gateway built in OpenWhisk, are there any third-party API gateways?
So the open source platform comes with one built in, and then the different vendors, so IBM plug our own, there's like an interface to plug your own API gateway in, so we integrate with our own. But it comes, the one that's built in is based on Nginx, so it comes with an Nginx one built in. So if I click, let's see how quick this is going to be. If I click create, hopefully this page should load in a minute, and it's going to allow me to really, really quickly create an API gateway. And yeah, so the nice thing is I can turn on all those features that we talked about, and hopefully it should give me back a nice public URL that's completely separate from the platform API. So it's not going to be, it's not going to use the platform API. It's going to be completely separate, and then we'll be able to kind of turn all those features. So it's a nice kind of enterprise pattern. Okay, I think the internet it was doing quite well earlier this morning, but I think it's got. Let's try. I'll refresh. It's making me log in. Okay, let's try this. I'll try logging in again. If it doesn't work, I'll quickly show you the video because there was a video backup, and then we can swap back. Okay, there we go. No, go away. Bad time. Okay, hopefully this is going to work now. Should we give it a countdown? 5, 4, 3, 2, 1. Okay, you're out of there. So let me, I have a, alright, okay, we'll try it again and see if this works. So I can give the API a name. I can say what the domain is if I've given it a domain. You can see here I can set up things like the routing, right? So now I can say, okay, when someone does /Bitcoin with this particular HTTP verb, I want you to call this action, and I want you to give me back some JSON, which is pretty nice. I can turn on all those features we talked about. So if I want to add authentication with a key, rate limiting, OAuth, cause, all I have to do is just say okay, and it should hopefully do it. Okay, much quicker now. This is good. So now I have this URL endpoint. So this is not the platform API of OpenWhisk. This is like the API gateway endpoint, but it should work in exactly the same way. So I should be able to say HTTP GET API Bitcoin. We'll give it the same parameters, amount like 10,000. Currency US dollars, and it should just work now, right? So boom, right? So the same serverless function being executed, same JSON coming back, but this time through the API gateway, and I could now go back in and turn on all those awesome enterprise features. I don't need to worry about it in the code whatsoever. So really, really quickly, in 10 minutes, we've gone from having some code on my laptop to code running a serverless function. Now I've got a public API that I can integrate within my application or give to other people. Let me go back by that. Okay. Okay, that's fine. So in the examples we've just been looking at, it's about using serverless cloud platforms to build some kind of API, right? Some kind of endpoint that you want to invoke programmatically and get the response back. But the other big use case, and maybe the bigger use case I think for serverless cloud platforms, is building what they call event-driven applications or event-driven architectures, where you're going to have your service functions automatically invoked by the platform whenever there's a new message on a message queue, a database has been updated, new file in an object store, and allow you to build this kind of event-driven architectures. And OpenWhisk also supports this through an entity we have in the system called triggers. So in OpenWhisk, you can create triggers which listen to those external event sources. So you can set up a trigger that whenever a message gets pushed onto a queue or your database gets updated, your trigger gets kicked off with those event parameters. And to do this, it's really, really simple. You use the command line, you say whisk trigger create, you give it a name, and then there's a parameter, --feed, where you give it the identifier for the event source you want to listen to and any parameters about how to be able to connect to it. And then once that trigger has been created, the platform will listen to that event source, that database, that message queue, and anytime there's an update, it's going to kick off the trigger with those particular event parameters. Now, all serverless platforms support this kind of event-driven architecture, connecting functions to event sources, so they're invoked automatically. But the event sources, the difference is the event sources they can listen to is very, very platform specific. So for example, these are the event sources currently come out of the box with OpenWhisk. So I have support for Apache Kafka. Kafka is a very popular open source message queue that you can set up and use with the platform. So whenever messages get pushed into Kafka, it kicks off your triggers with those parameters. Support for CouchDB, which is another very popular open source NoSQL database. There's one for RSS feeds, for mobile device events, for GitHub notifications. And then another kind of fairly common event source in serverless is what they call a scheduler or an alarm service, where you can trigger an event every 5 minutes, every hour, every 24 hours to be able to kick off background processing and kind of call your functions to do something in the background, like every day or every hour or something like that. And OpenWhisk has a kind of calendar event service that you can use to be able to do that. And when you've created your trigger, right, so it's listening to the external event source, in OpenWhisk you can create rules which bind together your functions to those triggers. So whenever the trigger gets fired with the message from the message queue, the platform's going to, with a rule, say, okay, I want you to call this function and pass in the parameters to be able to do that processing. And you can have multiple functions all listening to the same trigger, which is a really nice way to do kind of callback style processing. And again, to create rules within the system, you just say whisk rule create. You give the trigger the rule name and then the trigger and the action, and the platform will then bind them together. So whenever the trigger gets fired, the action gets kicked off automatically. So using triggers, we can start to build up these kind of event-driven applications and start to really build some nice new architectures using kind of the OpenWhisk platform. Now, hopefully, maybe you can see in the past half an hour why, or I've tried to explain why I'm personally so passionate about serverless cloud platforms, or why I think they're such a new and novel and interesting way to build software in the cloud. And hopefully you now agree with me, right, that servers are killing your productivity and you're ready to go back to your office on Monday and start setting fire to all your environments and get rid of them and start to use serverless. But before you do this, right, it's only fair that I talk about some of the challenges of using serverless cloud platforms today, because serverless is still a very new and emerging kind of technology space. It's not for everyone, it's not for every kind of workload, and there's definitely a number of rough edges that you might run into. So I want to introduce 3 challenges that people often experience, and then talk about some kind of mitigating strategies or things you do to kind of work around them. So the first big challenge people run into, I think, with serverless is around the compute limits, right? Serverless platforms are very opinionated platforms, and they are opinionated about the kinds of applications and architectures that they expect to run. You can't just lift and shift some legacy app and throw it over to serverless and expect it to work. Serverless is about running modern cloud applications designed to run and exploit the efficiencies of running in the public cloud. And one of the ways that the platforms enforce this architectural style on you is by really limiting access to some resources when you're running on the platform. So for example, this is a table of some of the limits and the kind of things that OpenWhisk kind of constrains you on a little bit. They're generally the same across all service providers. The 2 biggest challenges people run into, the first is around timeouts, right? When your function gets kicked off to process a request, you only have a maximum of generally about 5 or 10 minutes to be able to process it. If you haven't finished processing by that time, the platform just kills it off and returns an error code. That's like a hard limit you can't get around, and pretty much all service platforms have kind of settled on around 5 or 10 minutes as their kind of hard stop. So if you have some super long batch processing in your application, it's probably not going to, that takes an hour to compute, and you can't really parallelize the work or anything, it's probably not going to be suitable at the moment for running on serverless. Another big resource limit people run into is around memory. So with serverless, you get charged based on the milliseconds that your function's running, but also the amount of memory it uses during that processing time. And you can change the maximum amount of memory a function has available to obviously improve performance, but then also you kind of control cost. But the amount of memory you can allocate is, or choose your function to have, is in the order of half a gigabyte or a gigabyte, or maybe even 2 gigabytes on some platforms, but it's not like a terabyte. So if you have some super high performance algorithm that needs a terabyte of RAM to be able to compute really, really quickly, again, it's not really going to be suitable for serverless at the moment. It's much more for request response, fast event processing systems.